Hello again, everyone, and good morning. We're going to continue some more review for the EOC. Yesterday, you learned 7 rules of circles, and it was a review, and I want to see if you remember those from yesterday. If you do not, look back at your bell work and write them all, please. So let's take a look. Number 1 is called a central angle, and the angle and the arc are equal, so x is equal to 50 degrees. This one is an inscribed angle because the vertex is on the circle, so the angle is half of the intercepted arc, so x is equal to 25 degrees. This one is half the difference, so 50 minus 10 is going to give you 40, and then half of 40 is going to give you 20, so x equals 20 degrees. This one right here is the sum, so you add these two up. So 40 plus 10 is going to be 50, and then divide by 2. So 50 divided by 2 is 25. So x for D is 25 degrees. This one is the product, so it's follow that line, okay? A times B. A times B is equal to C times D, okay? This one right here is the tangent squared, so it's going to be 5 squared is equal to the outside, which is x, times the whole thing, which is x plus 7. Now this one you're going to have to do the quadratic equation on, just so you know. If you were to work it out, it's going to be 25 is equal to x squared plus 7x. Then you got to move the 25 over here, so that's going to become a negative 25. Then you got to set it equal to 0, which is what I just did. Now, A, B, and C. So it's x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Remember that formula? Okay, I'm not going to sit here and work it, but you do need to know it for that one. This one is outside times the whole thing. So the outside is 2. And the whole thing is 5 plus 2, which is 7, is equal to the outside times the whole thing, which is x plus 8. This one right here, too, you're going to have to do the quadratic equation. So when you do,
It just when I was passing, it wasn't doing the double sign, it was getting stuck, so it was a pain in the ass, so I have to do one by one.
I'm recording.
Thank you, yay. But it's fine now, okay?
Hey, thank you so much.
Have a good one.
Thank you. All right, so this is 0, so this is 1, 8, and negative 14. And then you got to do the quadratic equation on that one as well. All right, so now here we have to graph these lines. So this is a special line, so draw a graph. X is negative 2, so look at the tick mark. Make sure you put tick marks and not dots, okay? This one is y equals negative 2, so this is your y, so negative 2, put tick marks. And you can see this one is undefined slope. This is 0 slope. This one has a 1 right here, so put 1 over 1. So your y-intercept is negative 4. So go down 4, put a dot, and then go x. It's y's over x's, okay? So you're going to go up 1 and then to the right 1. Up 1 and then to the right 1. So your line looks like this. Make sure you know how to graph lines, okay? All right, we're going to do some more. On a new sheet of paper, put EOC practice. All right, let's work these. Give these a try. Well, this is plus 0, so your y-intercept on that one is 0. Okay. But here, move the negative to the top. You can move it to the bottom if you want. I'm going to go down 2 and then to the right 5. So down 2, 1, 2, 3, 4, 5. And that's how the line should look. Make sure you understand that. This one you have to get y by itself. So draw a line, move the 2x over here. So you get negative 4y equals a negative 2x plus 8, because there's a plus right there. Divide by negative 4. When you divide by negative 4, you get y equals 2 over 4, which you can reduce. You have one negative here, so it's going to be a negative 2. 8 divided by 4 is 2. This reduces to 1/2. Okay, so the y-intercept is negative 2, and then go up 1 and then to the right 2. Up 1 and then to the right 2, and you have your answer. Make sure you can graph those, okay? All right, now the reason why you have to be able to graph, and by the way, here's today's worksheet, okay? So you got a bunch of graphing here, all right? And I'll give you the answers as you work them. Now on this sheet right here, if you can't be with us, side 2, you're doing parallel lines, okay? So look here. This line is parallel to that line. These are alternating exterior and they're equal if the lines are parallel. This is 90 degrees. So 21x plus 6 is equal to 90 degrees. Then you got to work it out. Okay, find x right there. If they want to know the angle, it's 90 degrees because it's the same. This one right here is top. Those are corresponding, so they're equal. So 75 is equal to 11x minus 2, and then work it out. Okay, these right here are alternating interior, and they're equal. All right, let me find one that adds up to 180. Okay, remember there's only two possibilities. They're either going to be equal or they add up to 180 degrees. These are same side interior. These two add up to 180 degrees. So number 26, you're going to say 20x plus 5 plus 24x minus 1 is equal to 180 degrees. Make sure you know that. Okay, now let's get off of that. I'll have that worksheet for you. I still have to run it. But the reason why I want you to do that is because we're going to look at one of these problems in just a moment. But for right now, let's take a look at this diagram here. Okay, you're going to take that rectangle and spin it around that line, and what figure would it look like? Okay, well, it actually will look like this one. Okay, so you have to imagine that if you spin this rectangle, what would it look like? Okay, it doesn't have jaggeds like that. Okay, it would be smooth. It would be this one. It would be a pipe is what it would be. If you look at this one is a combination of a cone, which looks like this, the top part, and the bottom is a cylinder. So it's a cone and a cylinder. Okay, this one right here has a rectangular prism. Rectangular prism is a box, just so you know it. Okay, so the bottom is a box, and then you have some cylinders here. Okay, I don't see a cone, and I don't see a pyramid. Now this one right here is a cone up here, so I would say a cone. I would also say a rectangular prism because it looks like a rectangle. A cylinder, I think this down here is a cylinder, so I would say a cylinder. Okay, I guess you could say this is a pyramid. All right, I mean that's possible. It's either a cylinder or a pyramid. Maybe it is just a pyramid. All right, anyhow, I just wanted to go over that with you. And then another one that I want to go with you is this one. Now, pay attention to this one carefully, okay? Because on the EOC, you really have to do some thinking. So let me lower this a little bit, and we'll take a look at it. Now, watch carefully, okay? Close that window. All right, here we go. The question is, the vertices of this triangle are these. So the vertices are these points. And you're going to reflect it across one of these lines, and then you're going to reflect it across another line. And it says it's the same as moving 4 units to the right and 4 units up. Well, if it goes 4 units to the right, that would change the x by 4 units. Okay? So what you're going to do is add 4 to all the x's. Remember we talked about this. It's a translation. It's a sliding. And 4 units up is going to add 4 to the y. So you're going to add 4 to the y. Pay attention to this. So the new point, S prime, is going to be 5 and 8. Over 5 up 8. This one is 6 and 6. So R prime is going to be 6 and 6. And then finally, T prime is going to be 5 and 7. So let's graph that. So over 5 up 8 is somewhere over here. And we're going to put S prime. And then R prime is 6 and 6, so over 6 up 6 right here. So that is R prime. And then finally T prime is over 5 up 7, which is here. So that's T prime. Let's see how that looks. Now the question is, all right, we just translated it. So we want to see what can we do on these lines here. So put x equals 4. It looks like this. So if you reflect it over here, it would be somewhere over here. In other words, it would be 2 units, so you'd go 2 units here. This one would be 3, so you'd go 3 units here. This one would be 1, 2, 3 units, so you'd go 3 units here. So if you reflect it over the x-axis, it would look like that. The question is, can you make it? Let me make this a little smaller because I'm running out of work area here. The question is, can you make it look like this one? Okay, I don't think so. All right, even if you do one of these other lines, y equals 6 would look like this. Okay, and then it's probably one of these other ones is what I'm trying to say. Now I did work this one yesterday and I want you to look at it. So I ended up graphing this line here. Okay, this line here was the intercept of 6 with a slope of -1/1. So it ended up being that one. Okay, and then I had to reflect it one more time over this line, which ended up being 10. So it would have to be this one. What I'm trying to say is it was a lot of work. Okay, don't give up on it. You have to know how the lines look, and you have to know what reflections are in order to have a chance at figuring it out. All right, so today you have a worksheet 8 on graphing lines and parallel lines.